Here's example 12 of sum and difference formulas. So it's another identity problem. So the identity we want to establish is sine of pi over 2 minus theta equals the cosine of theta. So this might look familiar to you. So remember way long ago in the beginning of all these trig videos, we talked about what's called the complementary angle theorem. So remember the complementary angle theorem says co-functions of complementary angles are equal. So co-functions like sine and cosine are co-functions, secant and cosecant are co-functions, tangent and cotangent are co-functions, and theta and pi over 2 minus theta are complementary angles. So the co-functions of the complementary angles, they're equal to each other. Okay? So, but the thing with the complementary angle theorem was since the angles are complementary, they have to be acute. So in the complementary angle theorem, theta has to be acute. It has to be between 0 degrees and 90 degrees, or 0 radians pi over 2 radians. But this formula is actually true in more generality than just for acute angles. It's true for all values of theta. Okay? And the same thing is true for, if we swap cosine and sine here, or if we say the same thing with secant to cosecant and tangent to cotangent. There's those 5 other variations that we talked about way long ago in that other video. They're actually all true for all possible values of theta, as long as they're in the actual domain of the function. For sine and cosine, the domain's all real numbers, so we don't have to worry about that. But for the other 4 trig functions, we kind of do have to worry about that. But anyway, so now, so what's kind of cool is using this sum and difference formulas, we can establish this for all values of theta, not just for the acute angles. Okay? So when we talked about it for the acute angles, we use the right triangles to show, but now we can just use these formulas on this formula sheet. And if you want a copy of this, check the video description, there's a link in there, click the link to get a copy of this. So anyway, what do we have here? So we're establishing identity. It looks relatively simple, but when you establish identities, always start on the more complicated side and just leave the other side alone. Okay? Or usually start on the more complicated side, but anyway, what you always want to do is always just start on one side, pick only one side, work on just that one side, leave the other side completely alone, and almost all of the time you'll start on the more complicated side. So this is definitely a little more complicated than that, so we'll just start with that more complicated side. So sine of pi over 2 minus theta equals, so notice it's sine of something minus something else. So we're going to use this version of the formula here, sine of alpha minus beta. So this right here, this is going to be our alpha, and this is going to be our beta. Okay. So pi over 2 is our alpha, and then theta is our beta. A lot of Greek letters flying around all over the place here. So sine of pi over 2 minus theta, so sine of alpha minus beta is going to be sine alpha cosine beta minus cosine alpha sine beta. So this is sine alpha times the cosine of beta, okay, sine of alpha, cosine of beta, minus cosine of alpha, which is pi over 2, alpha is pi over 2, times the sine of beta. Okay. So all we did was we just took the formula here, sine of alpha minus beta equals this mess, and we applied it to this expression right here. Okay, that's all we've done. So now let's simplify. So sine of pi over 2, we know that from the unit circle, sine of pi over 2 is just 1. Cosine of theta is just cosine of theta. Cosine of pi over 2, we also know from the unit circle it's 0. Sine of theta is sine of theta. 1 times cosine of theta is cosine of theta. 0 times sine of theta is just 0, so this term just completely goes away. So all we're left with is cosine of theta, and that's exactly what we wanted. Okay? So it might almost seem anticlimactic a bit, because it's really just, use the formula and then simplify a little bit, and that's pretty much it. So this establishes the complementary angle theorem for this specific pair anyway. Not just for acute angles, but for angles in general. Because remember, this formula applies for all values of alpha and beta. Okay? So pi over 2 is just pi over 2, but theta can take any value, not just acute values. So that's great. That kind of establishes that in more generality. So that's one way to do that there. Anyway, that's example 12 of sum and difference formulas establishing this identity here.